I'm Piotr Szymaniak and I'm from Netictech. Netictech is a company that's mainly focused on stimulation of interesting ideas. One of these ideas is medVC. It's a teleconsultation platform for doctors. It allows audio-video interaction, provides several HD video streams simultaneously. It provides also dedicated services. It's able to interact with video imaging devices on operating fields. Actually, medVC, we had a problem in medVC. Why we came to FEC1? We had a problem that medVC requires desktop terminal in order to access to the platform. So the doctors don't always have a desktop terminal, don't always have access to the desktop terminal. Therefore, we developed a mobile application. However, we have had no idea how the mobile application will perform in real-life scenarios. We came to FEC1, we came to perform LTE testbed and asked them for help in evaluating the performance and operation of the medVC mobile application. So the challenges that they helped us to solve is that we have little expertise in LTE, so we didn't know what are the parameters that are interesting from our perspective, from our application level perspective. We didn't know how to design experiments that will reflect on real-life scenarios. And we required some help also with interpreting the results. And of course, we were lacking hardware and software in order to properly measure the operation of our application in real-life scenarios. So the testbed and FEC1 helped us with that. We have created a setup which consisted of a desktop medVC terminal, which was located in Poznań, and the mobile medVC terminal on the cell phone located in the testbed. The cell phone and the application also was interfaced with eNodeB emulator, so the emulator of the LTE network. We're also doing measurements of power consumption in order to verify that the power consumption is not a problem in our use case scenario. So we have done tests in 3 scenarios: the stationary scenario, the pedestrian scenario, and the vehicular scenario. So the stationary scenario was the speed was set at 0 kilometers per hour, and the signal-to-noise ratio was 20 decibels. In stationary scenario, the speed was 5 kph and SNR was also 20 decibels. In vehicular scenario, the speed was increased to 70 kph. And in order to make up for the lower signal strength in the cars, the signal-to-noise ratio was lowered to 10 decibels. We have received several results. We have actually been doing tests in 2 HD resolutions, 4 bit rates, and to get some basic average, we have done 3 experiment runs for each configuration. So overall, we had 72 runs of the experiment. And here are some basic results. You can see how it looked like from our side, from Poznań side. We were sending the video, the medical video, to the testbed, and the testbed was sending us the video grabbed by the camera and the cell phone. So the conclusions that we were able to get from the experiments is that the QoS, the quality of service provided by mobile application and LTE network, is acceptable. Namely, the packet loss ratio was classified as good. The sequential errors rate, there were some, but the level of them was acceptable. The mobile application was able to comprehend with them. And the inter-packet arrival times were correct. Skew, delta, other timing values were acceptable as well. Apart from the QoS, we were also able to measure the power consumption, and we did not identify any abnormalities here. And apart from the LTE network, we were able to also measure packet overhead values, which is somewhat not related to the network you are using. So maybe more important is what on the business level this experiment brought us. And the top level outcome is that the medVC mobile application is compatible with LTE network. So the quality of service is satisfactory for the medical users. The quality of experience will be enough to provide medical consultation. And we have a new product that can be shipped, that can be added to our product suite, that can be offered to customers. In the close future, however, we will be able to provide mobile doctors remote consultation. So the doctors would not have to be bound to the desktop terminals. They can be traveling, they can be using their tablets, they can be using their mobile phones in order to provide consultation services. Students do not have to be confined to operating rooms or the conference rooms. They can take their mobiles and take part in the operation remotely. That's the medical education scenario that we are envisioning here. And also there is completely new market share that we intend to gain in patient to doctor services. So the patients can now use their phones in order to get medical services like consultations, like follow-ups in their medical procedures. Why we came to FEC1 is also because FEC1 provided us with help, with support, with the tools. The most important thing was, I believe, the support. We were lacking expertise in LTE, and this is the thing that they helped us mostly. Would we do this experiment without funding? It would depend on the perhaps not to this level of not so in-depth experiment, because of the funding we were able to focus more and get more in-depth outcomes from the experiment than we would be able to do without the funding and without FEC1.